guys?
Well,
What is up, guys? It's Raimi, Mark, and Owen from the Raimi Bogner original film, Mark's Soccer Story. So I play Raimi in the film. We have Mark, who plays Mark, and then Owen, who plays, well, Owen.
the amazing soccer superstar.
So, I mean, this story taught us a lesson about believing in yourself. And not only that, but it also taught us about physics.
Yeah.
It also taught us about physics. So, Mark, why don't you break down some of this physics?
First, I want to say we've come a long way from Owen getting sidetracked by Max being just a whole bunch of other problems.
We lost a couple of members along the way, but
In the end, it turned out to be a good product.
it did.
So, yeah.
All right, give me that.
Alright, all this, it all relates to physics because soccer is one big physics thing into a game.
All right.
Alright,
So, I mean, if you look closely, you can see all of the energy conversions throughout our phone. I mean, there's thousands of them. One of our biggest ones was, we're all going to do one energy conversion. One of our biggest ones was the energy from the food that you eat going into the actors. I mean, the only way that our little stores over here could have done anything was with the food that they ate. Oh, and can you name a second one?
So, an energy converter would be like the nuclear energy coming from the sun, supplying your body, which is chemical energy, which is then turning into potential energy, which then turns into kinetic energy as you start moving.
All right, Mark, what's your normal?
One of the most important things, soccer, dribbling, shooting, you want to score the goals, you want to win,
Of course, of
you want
course.
to be a legend. So when you put the ball down,
Of course, Mark, continue.
when you put the ball down, yeah,
Okay, well,
when you put the ball down, and you get ready to shoot, you're storing potential energy in your body. You're moving, that's kinetic. It's transferred to the ball. The ball is storing potential energy just as you are. And then it moves with that kinetic energy. And the gravitational pull is what moves it. And it always flies down. And how you kick it, it makes the ball curve or something into the net.
100%, 100%.
Alright, so acceleration is like how fast an object can move, like the speed.
Okay.
And the formula for acceleration is final velocity minus initial velocity divided by time.
It's an amazing formula, honestly. Let's take a look at
This
this.
is awesome. I'm going to do
In-
Yeah, mine too.
So, I mean, acceleration. So, acceleration is pretty much the science of how fast something is moving. Like, you know, if I don't kick a ball, it's accelerating. It's not accelerating, it's not moving. But when Mark kicks a ball with all his power, which you can see in the new movie, Mark's Soccer Story, it really shows the power and the force. It's just amazing.
Basically, stuff
It's just truly amazing. Good?
What did you guys do?
Nothing.
So,
You got my ISD.
it also demonstrates, I mean, all the laws of motion, really. Newton's first law was, Mark, why don't you explain Newton's first law?
I did a conclusion for Miss Hickey on Newton's first law, and I did a lot of research.
Mark, you have to sit down. So we the camera can see as well.
This is kind of my specialty.
What, do you know Newton's first law?
Newton's first law.
Newton's first law was, Mark, why don't you explain Newton's first law?
I did a conclusion for Miss Hickey on Newton's first law, and I did a lot of research.
Mark, you have to sit down. So we the camera can see as well.
This is kind of my specialty.
What, do you know Newton's first law?
Newton's first law.
What's up, dog? Sorry. No, dog is
Is mine? So Newton's first law states an object in motion,
will remain in motion until otherwise.
unless acted upon by an outside force. That's soccer. Soccer's motion. You're running,
And
running.
the second part of it is an object at rest will stay at rest or must act on by another force.
Of course. I mean, I think that shows, like, with the ball, if you hit it, it's not stopping unless the goalie stops it.
And if you're running, and then there's many people running on the field.
Oh, of course.
So when you're running, you can stop with a collision with another player. Bam.
You're done. You're on the ground.
You're done.
All right. I'll take Newton's second law.
All right, go.
So, Newton's second law states that there is a equal and opposite reaction for every action.
That's third law.
So I'm taking Newton's third law then,
No.
and it states that there is an equal and
Yeah,
opposite reaction for every action. And that strongly applies to soccer. If Mark kicks the ball, not only is his foot taking back some of the force, but the ball is taking to some of it too. And that ball is going back down the field. Oh, let me take that second law.
Alright. The second law of motion is if you use an object with the same amount of mass and you kick it with either a harder or softer force, it will accelerate or decelerate quicker or slower. So like if you kick a soccer ball really hard, it will go farther than if you say like tap a soccer ball. One will go a lot of yards, one will just go a couple of feet.
Okay. Alright, guys.
You need velocity. Alright, so.
Oh, okay. I'm gonna get a cat.
You have a cat?
It's a Garfield.
Jesus Christ, you have a cat?
Alright,
Oh my
so
god!
for velocity.
Wait, you got a new cat?
Yes, alright.
Alright, let's keep going. I'm gonna go pat that cat over.
No, you're not!
Let's keep going.
Alright, so for velocity. It's a boy too, so.
Oh my god!
Alright, so for velocity, right?
Go pussycats.
It's like how fast an object can go before it stops
It
accelerating.
can go 0 to 100 real quick.
So the formula for velocity is
Something with that.
mass divided by acceleration. Yeah. Alright, so who wants to do speed?
Or just speed.
Alright.
So speed is pretty much just how fast something is moving. Speed is distance over time. So especially with soccer balls, or really any type of ball in general. If you kick that ball, it's going a certain amount of miles per hour. It's a big ball. It's going a certain amount of miles per hour. That's the speed of it. Flash is like the speed of light. Mark's soccer balls, they're the speed of a dinosaur. Some fast stuff.
And that
It's our forces project.
We didn't.
Yeah.
Wait, stop, wait.
It's getting.
We didn't do the forces stuff like air systems. and
Yeah, we
gravity.
did.
Alright, so
So it turns out we might have skipped a couple things along the
When
way.
you're playing soccer, especially in the wind, right? It's windy. It's gonna affect the ball. When you kick it, that wind is pushing against the ball.
Which creates air resistance.
Exactly.
and then there's also gravity for when you kick a ball up in the air so it comes back down. Right? And
Yeah.
Alright, and applied force is when you're kicking the ball to make it move.